Adding and subtracting polynomials with algebra tiles notes. In polynomial expressions, there may be a variable squared, for example, an x squared. For x squared, we will use this algebra tile. So let's draw that one on our notes. If you flip it over, the red represents a negative x squared. There may be a variable, for example, x. For x, we will use this algebra tile. So let's draw that one in our notes. If you flip it over, the red represents a negative x. There may be a constant. Remember, these are the numbers with no variable. For example, 1. For 1, we will use this algebra tile. So let's draw it in our notes. If you flip it over, the red represents a negative 1. Okay, so our first problem says negative 2x squared plus 3x plus negative 7x minus 2. Let's start with the first polynomial, negative 2x squared plus 3x. The first term, negative 2x, tells us we need 2 of the x squared tiles. But because it is negative, we need to flip them to the red side. Then it says plus 3x, which tells us we need 3 of the x tiles. Now, underneath this, we will place the second polynomial. The first term, negative 7x, tells us we need 7 of the x tiles. But because it is negative, we need to flip them to the red side. And we place these under their like term from the first polynomial. So are these like terms? No, one's a big square and the other is a rectangle. Are these like terms? Yes, so we will place them here. Then it says minus 2, which tells us we need 2 of the 1's tiles. But because it is negative, we need to flip them to the red side. And remember, we place these under their like term from the first polynomial. And if there is no like term, then in the previous polynomial, we will place the constants at the end. Okay, so the problem says we want to add them, So let's put an addition sign and a line underneath. So let's copy this down onto our notes using colored pencils or markers. So now we want to look for what we call zero pairs. A zero pair is when they are like terms but opposite colors. Like here, we have some green rectangles and some red rectangles. So we will take one of each, like this, and they go away. And then we do this again and again until there are no more zero pairs. So now whatever is left, we bring it down, and that is our answer. So bringing it down. Let's copy this onto our notes real quick. Now what we want to do is translate it back into numbers and variables. So we were left with two big red squares. So remember that the big squares represent an x squared, and there are two. So then it is 2x squared. But remember that the red means that they are negative. So negative 2x squared. Then we have 4 red rectangles. And the rectangles represent an x. If there are 4, then that is 4x. But again, because they are red, that means that it's a negative 4x. Then we have 2 small red squares, and the small squares represent a 1. And if there are 2, that is 2. But once again, because they are red, that means it's a negative 2. Now we just box in our answer. Any questions? Okay, let's look at our next problem. 3x squared minus 5x minus 2 minus x squared minus x plus 1. Let's start with the first polynomial, 3x squared minus 5x minus 2. The first term, 3x squared, tells us we need 3 of the x squared tiles. Okay, so 3 of the x squared tiles. Then it says minus 5x, which tells us we need 5 of the x tiles. But because it is negative, we flip them to the red side. Then the minus 2 means we will need 2 of the 1 tiles. And again, because it says minus 2 or negative 2, we flip them to the red side. Okay. Now, underneath this, we will place the second polynomial. The first term, x squared, tells us we need 1 of the x squared tiles. Because there is no number in front of the variable, that means it is a 1. And we place it under the like terms from the previous polynomial. So these are like terms, so we place it here. Then it says minus x, which tells us we need 1 of the x tiles. But because it is negative, we need to flip it to the red side. And remember, we need to place it under their like terms from the first polynomial. Then it says plus 1, which tells us we need 1 of the 1's tiles. And remember, we place it under the like terms from the first polynomial. Okay, the problem told us that we need to subtract them, so let's put a subtraction sign and a line underneath them. But when we are subtracting, we can change the sign to an addition, and when we do that, we must flip all the tiles after the sign, and that'll change them to their opposite. So we flip this one, so it goes from positive to negative. Flip this one, goes from negative to positive. Flip this one, goes from positive to negative. So let's copy this onto our notes. So now we want to look for the zero pairs. Remember, a zero pair is when they are like terms but opposite colors. So we look for, are there any zero pairs in the big squares? And we say yes, because we have some blue big squares and a big red square. So we would take one of each, like this, and then they go away. Then we ask, are there any zero pairs in the rectangles? And we say yes, because we had a green rectangle and some red rectangles. So we would take one of each, like this, and then they go away. Then we ask, are there any zero pairs in the small squares? And we say no, because both of these, or all of these, are red. So now whatever is left, we bring it down. And let's copy onto our notes real quick. Now what we want to do is translate it back into numbers and variables. So because we have two big blue squares, remember that the big blue squares represent an x squared. So if there's 2, we say that it's 2x squared. Then we have 4 red rectangles, so we would say 4x, because 4 rectangles, and because they're red, we say it's negative 4x. Then we have 3 small squares, and the small squares represent a 1, so if there's 3, we say 3. And because they're red, we need to put a minus in front of them, or in front of it. Now we just need to box in our answer. Any questions?